afternoon, everyone. Welcome to the Invasive Mussel Collaborative webinar, Zebra Mussel Control in Lake Winnipeg. This is Erica Jensen with the Great Lakes Commission, and on behalf of the Invasive Mussel Collaborative, I want to thank you for participating in today's webinar. I have a few introductory and logistical remarks before we get started in our presentation, so thanks for your patience while we go through those. For those of you who are not familiar with the Invasive Mussel Collaborative, we are an initiative working to advance scientifically sound technology for management and control of invasive Dreissenid mussels in order to produce measurable ecological and economic benefits. The collaborative provides a framework for communication and coordination, identifying the needs and objectives of resource managers, prioritizing supporting science, developing communication strategies, and aligning science and management goals into a common agenda. If you'd like to know more about the Invasive Mussel Collaborative, we encourage you to visit our website at www.invasivemusselcollaborative.net. The website has recently been updated and includes information on the collaborative, mussel biology, management, research, and recordings of past and future webinars. We encourage you to use our new forms on the research page to submit current research projects or publications that you have been involved in or are part of the mussel research and management community so we can make them available to others to access. We also encourage you to join our Invasive Mussel Collaborative listserv if you have not done so already. By joining the listserv, you'll receive webinar announcements, you'll get updates about recent news, and be able to connect with other researchers and managers. A link to join the listserv is provided on our website. Today's webinar is part of a broader series of webinars hosted by the collaborative. The purpose of the webinars is to facilitate learning and information sharing on topics related to management and control of Dreissenid mussels. It will be recorded and archived along with other webinars on our website. In terms of logistical items, again, today's webinar will be recorded and it will be posted on the website within a few days. We are also pleased to have more than 100 people registered for the webinar, and due to this large number of people participating, all attendees' lines will be in listen-only mode for the duration of the webinar. Attendees will remain muted, and we will be taking questions, but we will be taking questions in written form only. So if you have a question, you may type it into the questions pane of your GoToWebinar dashboard. Questions may be submitted at any time during the webinar. However, we will not be answering them until after the presentation has concluded. We will do our best to take all questions or comments during the hour we have allotted for today's webinar. If you have to leave the webinar before we have gotten to your question, we encourage you to review the recording that will be posted on our website to hear the answer to your question or to follow up with us after the webinar via email. If you are experiencing technical difficulties, you may send a chat to one of the webinar organizers, Great Lakes Commission or Erica Jensen, and we will try to help you resolve your technical issues through the chat function. So I'm pleased to welcome Laureen Yanish with the Manitoba Aquatic Invasive Species Program and Dan Butts with ASI Group to share their experience with zebra mussel control efforts in Lake Winnipeg for today's webinar. Laureen has worked with the Wildlife and Fisheries branch of the Manitoba Conservation and Water Stewardship since 1987. In the earlier years of her career, Laureen was involved in stream restoration efforts, and over the last decade, her main responsibilities have been regulatory review, fish health, and permitting. The unfortunate discovery of zebra mussels in Lake Winnipeg happened to coincide with the Fisheries Branch Aquatic Invasive Species Specialist being out away on maternity leave, and so Laureen found herself immersed in responding to the issue. This experience, which will be one of the highlights of her career, was certainly enhanced by the cooperative and collaborative efforts of all those involved, both within and outside of government. Our second presenter, Dan, is currently manager of biofouling services at ASI Group Limited, which specializes in engineering, ecological, and marine services for industries and municipalities worldwide. His experience in the ecological industry spans over 25 years and includes development of zebra mussel control protocols and installations, biofouling turnkey treatment systems, fire protection system control, client relations, and contract administration. So with that, we are ready to get started on our presentation. Laureen, we are going to hand off presenter status to you so that you may get started.
Okay, I'm just working through here. There we go. Can you see my screen?
I can't.
You can't?
Not yet.
Okay, application is paused. Just 1 second here. Okay.
There you go.
What about now?
Now we've got it.
Yep.
Super. Worried there. Erica was just telling how things have been successful so far in these presentations, and I said, let's hope that continues for this one. So thanks to Erica and Sarah for inviting us to present, and I would like to also welcome everybody who's sitting in on the webinar today. I want to sort of cover a bit of a background about Lake Winnipeg, what our program was like pre-zebra mussel, and then how we responded with that initial detection, the treatment options that were considered. We'll switch over to Dan to talk about the actual treatment, and then if time permitting, we'll look at post-treatment and going forward. So just briefly, I wanted to sort of give everyone a background on Lake Winnipeg. It is the 10th largest freshwater lake in the world. It is made up of 6 major drainage basins, and all that receiving water ends up flowing through the lake and out through the only outlet, the Nelson River, which eventually enters the ocean at Hudson Bay. So it is the downstream receiving end of a lot of water. It's also distinct in that it has 2 distinct basins, a south basin and a north basin. The south basin has an average depth of about 9 meters and the north of about 13.3, and then this narrow channel that connects the 2. So the resident time for the water to flow through Lake Winnipeg is roughly 3 to 5 years, and it's because of its shallow depth in general, it doesn't typically stratify. If it does, it may be in the North Basin, but for very short periods. The other thing to know about this lake, it has a significant commercial and recreational fishery, and considerable tourism dollars generated by folks coming to visit or recreating at Grand Beach, Winnipeg Beach, a lot of the popular beaches on the South Basin. The other thing is that we are also in close proximity to large basins with many aquatic invasive species. So we have the Mississippi River Basin with approximately 120 AIS, and the Great Lakes with more than 200. And until the zebra mussel invasion, we had roughly 15 aquatic invasive species. Spiny water flea and rusty crayfish were among those. The other thing, not just the location, but whether we would be a suitable host, or our water bodies would be a suitable host should zebra mussels get introduced. And we know from a national risk assessment on zebra mussel, quagga mussels, and dark false mussels done by DFO that many water bodies would support high, my arrows here, high to moderate levels of infestation. And so that's a considerable concern. If you look there, Lake Winnipeg, oh, there it is. It's just along this border here. We also know from watercraft inspection data that we are getting a lot of boating traffic from the United States, and in particular from states with water bodies that are infested with zebra mussels and other AIS. So prior to zebra mussels, Manitoba's Aquatic Invasive Species Program primarily focused on prevention and education. We were fortunate to have a 13-year watercraft inspection program at the International Border Crossing at Emerson, and we focused a lot of education and outreach during the summer targeting high boating traffic areas and events, participated on a number of national and international jurisdictional AIS committees. Our resources at the time, 1 full-time AIS person and 2 step students during the summer, an annual budget of $40,000, which came from a department fund and was directed primarily to operating the watercraft inspection program, with some monitoring for zebra mussel veligers, We are fortunate to be able to apply and receive money from various funds, in particular the Fisheries Enhancement Fund. And to top it off, just before in July, our AIS specialist went on maternity leave, and a decision was made not to underfill or not to backfill that position. So I guess it shouldn't have been a surprise when on October 11th we received a specimen that was suspected to be a zebra mussel. That is that individual right there. We were in a position where we've had a Canada-Manitoba AIS task group that was formed under the Canada-Manitoba Fisheries Advisory Committee, so we were able to contact our co-chair at DFO at the time, Scott Higgins. He was able to confirm but suggested that we send that zebra mussel off to Jerry Mackey for further confirmation and just ensure that it wasn't a quagga mussel. We did that, and I have to admit it gave us a little bit of time to set that internal panic button, and particularly when we went out to the marina where this zebra mussel had come from, and proceeded to look under the docks and found more zebra mussels attached. So how did we respond? A lot differently than how we were feeling internally. We ended up implementing we implemented a framework from Locke et al. We didn't have a Manitoba-specific one at the time. And with that framework, for those that are familiar, it consists of 6 stages identified in the post-invasion process of detection, demarcation, containment, risk assessment, implementation, and follow-up. I'm only going to touch on those areas as they apply to the potential to treat, as that's part of this discussion today, and not other components of the program. One of the key pillars of this framework was establishing a science advisory committee, and here we were fortunate to have Jerry Mackey, Renata Claudy, Scott Higgins, and then government individuals, Justin Shedd, Jeff Klein, and Jeff Long on the committee. That external science committee was so critical in terms of providing us with direction regarding the data to be collected, reviewing that data, assessment treatment options, providing a recommendation. They were available for conference calls, for public meetings, ended up dealing with the press, and so it truly, that was a lifesaver, having the formation of that committee and those individuals. So we really needed to, as I mentioned, we found the zebra mussels October 11th. That's already getting towards the end of the open water season. So we had to find out the extent and magnitude of the infestation, at least collect as much data as possible. In the interest of time, I won't get into the specifics regarding the level of detail that went into that, but we were fortunate in the end to have approximately 5 weeks of open water. The last field entry was November 16th with water temperatures at 1.6 degrees. And all I can say is it was darn cold. So we were able to field as much infrastructure as possible, checking shorelines, docks, starting from Gull Harbor at the upper end of the north part of the South Basin, going all the way around almost to the opposite side. At that time, we'd identified in red locations where zebra mussels were found. What we didn't know is whether they were established at depth. So what I mean is every place we'd found them, they would probably be within the ice, formation of the ice come winter. We hadn't found anything that would survive that 1.5 meter ice depth. So we were, through our relationship with DFO, we were able to get the Freshwater Institute dive team to come out, and they did an in-depth assessment of the 4 harbors. And based on all the evidence that was collected, it was determined that we were at an early stage of infestation, largely contained to the 4 harbors: Silver, Gimli, Winnipeg Beach, and Balsam Bay. I'm overlooking Willow Point here because it's a shallow harbor, and so it was felt that it would freeze to the ground during the winter. So what were our options? And again, the SAC was pretty instrumental in looking at the options that were available. None of us truly felt that no action, and it was supported by the department, that no action was not an option. We looked at hand picking, resuspending sediments, dewatering the harbors, potential for equinox, reducing pH, copper sulfate, using chlorine, or potash. And I have, you won't be able to read this very well, an excerpt from a report that was done by the Canadian Science Advisory Secretariat. In the end, this report is probably one of the only published documents that is out there that outlines the pros and cons of these particular processes and recommends or ends up mirroring the recommendation of the Science Advisory Committee. So in the end, we recommended, or potash was recommended as treatment. It was selected for a number of reasons. Really, it comes down to the fact that it was known to be 100% effective. It was considered the most environmentally benign option. It had been used successfully elsewhere, i.e. in Virginia, and that was really, in the end, key, I think, for us getting some of the permitting requirements we needed down the line, and affordable and possibly logistically achievable with a tight time frame. Our overall intent was at minimum to apply downward pressure on the zebra mussel population and reduce the spread of zebra mussels from the harbors by applying this muriate of potash at a concentration of 100 parts per million between ice breakup and before water temperatures reach 10 degrees. And we were hoping to have ASI group do it, as they were the consultants who had done the successful work in Virginia. I just don't know how to communicate. In many senses, this was rapid. But we were so fortunate with the winter months, because what we found ourselves is in the position of doing many things concurrently. So trying to get internal approvals to treat and for funding, regulatory approvals, meeting with stakeholders, and it wasn't the most ideal circumstances in all cases. It did result in, you know, some accusations, I guess, of not being transparent and not being able to consult with people as much as they maybe would have liked, and did also cause a change in the way the treatment was done, which Dan will talk about in a little bit. The other hurdle, of course, is that in Canada at the time, there was no known product that was registered for open water use, and so the key thing was whether we would be able to get the approval to do that. In the end, and I won't go through this in great detail if you need to look at it afterwards, this summarizes the federal approval permitting that we needed to go through or not, with reasons if not, provincially, and then in the end we had to form a couple of committees. One was one between DFO and Manitoba, and this was really to provide a mechanism for collaboration. The small craft harbors was owned by DFO, and it did involve, or the administration of those harbors were done through the harbor authorities. So we had some stakeholder overlap, and the implementation committee, again, really rose due to this fact that some key stakeholders had some concerns about this, and so we brought the committee together to try and facilitate more frequent dialogue with this group and get their input. So with that, I'm going to switch it over to you, Dan.
All right, thanks, Lorraine.
We'll hand off presenter status to you, Dan, here. Just give us a couple seconds.
No problem.
All right, you should be good.
Okay, great. And you can see my screen now?
Yeah.
Okay, great. Well, good afternoon, everybody, and thanks for joining us for this webinar. My name is Dan Butts with ASI Group, and I'll pick it up from here. Just a first slide showing, denoting the harbors that were actually treated during this process in the spring of 2014. The path forward for us was that in early March, the province had decided to proceed with the eradication attempt. And as part of that, access to and from these impacted harbors would be restricted until the eradication attempt was completed, and that was specifically targeted to boating, pleasure craft or commercial fishing were the two main proponents that use these harbors. ASI Group, we approached the treatment strategy using potash as the control agent, and we were chosen because of the reasons that Lorene outlined, and also because we'd done this successfully in Millbrook Quarry, which is located in the state of Virginia, and we did this in 2006. We did, prior to mobilizing our equipment out, we did a site inspection at the end of March to come out and see logistically what had to be done. Unfortunately, it was so cold when we were there, and all we saw was ice and snow. There was really a good feel for what was underneath, but it did give us a great opportunity to put faces on each other for the clients that we were dealing with and them with us. So just a bit of a background on Millbrook Quarry. It was the successful eradication. And one of the reasons for that is the quarry wasn't fed from any surface water, rivers or streams. It was only recharged by groundwater, and that really helped us to maintain the concentrations we needed during that treatment. So I felt that the only chance of reasonable success at Lake Winnipeg, in the Lake Winnipeg harbors, was to replicate our experience there. But the greatest difference between the two is the fact that these harbors were actually open to the lake, as they all are. So this is a picture of Winnipeg Beach, and I think it shows a little more clearly here at Silver Harbor about how it opens up directly to the lake. So we were faced with trying to replicate what was happening in Millbrook Quarry, and the way we did that was to install barriers. So this is another harbor that was treated, Balsam Lake. It was the smallest one, and we used silt curtains to create an enclosed system. So the curtains completely barred off access to the lake. And once this was done, we were able to apply the liquid potash to get to the target concentrations we needed. And that was the proposed methodology that we sent to the province, and that was ultimately accepted. And this is just a typical layout of the silt curtain. So across the top, there's flotation, and then along the bottom, there's a heavy chain that allows the curtain to hug the contour of the bottom. And we also dove in to install additional ballast just to be sure it wasn't going to move. We did run into some problems, as Lorene alluded to before, because the harbor access was restricted. That impacted people who make their living from the harbors, the commercial fishermen. So when it became public knowledge that this eradication attempt was going to happen, there was very strong backlash from the people impacted by this. So we came to a meeting in Winnipeg where we met the implementation committee, and we met the members of the government, and we were tasked at that point with redesigning the silt curtain that we'd originally proposed to allow boat traffic to traverse it. So this happened on about the 10th of May, and we started on the 21st. So we were kind of really faced with a dilemma of creating a silt curtain that would satisfy those conditions. It hadn't been done before, and it was really kind of a nod to our marine staff and our engineers, because what they came up with was really, it worked well. It completely did the job. So here's just another shot of that. So what we've done is we've taken out a 20-foot section of that flotation and added in a basically channel iron that would hug the curtain, and we also welded a hollow tube to the top that we could pass a cable through. So and then we used a manual winch located on the shoreline, and simply we let the slack go, and then the weight of the channel carried the curtain down so that shipping traffic could go over top of it. Once that was completed, we rose it back up, and I think that there's a great shot of it right there. This system really worked well. Okay, so now we're getting to the point where we're actually going to do the charge. We call it the potash charge. It's potassium chloride. We mobilized to the site on May 19th, and we proceeded to set up our chemical injection storage facilities. We launched our boats, prepared the hose for use, met with all the stakeholders, and there were all kinds, from government people to press. Everybody was interested in what we were doing. And we also had a great meeting as well with conservation officers. And again, these are the staff that operate at the winches 24 hours a day, 7 days a week. If any boat traffic needed to come in the harbors, they were staffing it to make sure that happened, and they did a great job. This is our temporary tank farm. It was really key, and it was also another difference between this job and Millbrook Quarry. At Millbrook Quarry, we sat the tanks in place and they never moved. For this, we had to move tanks to each harbor, so we were able to get a trailer-based tank system. We simply backed it into a spill containment and lowered the wheels, and it was ready to go. When we needed to move to a different harbor, we simply hooked the trailer up to the truck and pulled it away and moved on to the next location. This is our hose assembly. We had about 1,900 feet of 1-inch hose, which basically were connected back to the tank supply system. And every 6 feet we attached about a foot of insulation that served as flotation for the hose. If the hose did not float, the job would not have gotten done. So it was key for us being successful, and it was in Virginia at that time as well. Our potash was delivered to the site daily. We took certainly 5,200 gallons per fill, and sometimes that was 2 to 3 times per day. It was liquid potash, 20% potassium chloride. Our tanks were connected in parallel, and then that was gravity fed through booster storage pumps. And we had 2 pumps that were loaded in series, and a minimum of 12,000 gallons was pumped per day. Sometimes it was much higher than that. Potash entered the Sealander, which is our application vessel, and it entered at the top of the vessel is a 360-degree rotating valve. So that's what connected to the tanks on shore. Because it was 360 degrees, we were able to maneuver the boat without tangling the hose. It's very important to the process. And then the chemical came down to the, let me just point this out here. This is a distribution pipe on the front with 6 leads that were about 10 feet. This allowed us to disperse the chemical into the water and at depth. These lines were actually perforated from bottom to the top of the water surface to help with the mixing. Depending on the size of the harbors, each area was divided into treatment zones, and those zones were treated individually. We could change the length of the hose depending on what we needed. If a smaller harbor needed less hose, we could take some pieces out of line, and that just increased the flow rate for us and increase the or decrease the amount of time we needed to treat each harbor. Before we started, though, we collected background samples to get the background potassium levels, and they all fell in around the 4 to 12 milligrams per liter level. The actual charge activities began on May 19th, and they concluded on June 12th. While we were doing the potash charge, we collected samples daily to see where our concentration was at. We were shooting for 100 parts per million potassium as potassium, and we were also looking for our water temperatures. And they were collected at key locations within the harbor. So, if there was any small offshoots that you would absolutely want to make sure you got good mixing in, we'd be sampling in there. And we did log the GPS coordinates of these locations as well. Bioassays were also used so we could measure the success of our treatment. We did need to get a permit from the Conservation and Water Stewardship to bring zebra mussels to Manitoba. And being from an infested area, it's just something you take for granted. If you do work, you would go get your test organisms and just use them. Well, we couldn't do that here. First of all, we couldn't take coaga mussels in. And we had to make sure that our source was completely composed of zebra mussels, which is pretty hard to find in Ontario these days, but we were able to do that. And then we had a permit, again, from Loreen to bring it into the province. And once our charge activities were well underway and almost finished, we started to deploy these bioassays in each harbor. There's about 35, and they were deployed in strategic locations And we also had at the Gimli Harbor a recovery system in place, and I'll explain that a little bit more in detail as we go through the slides. But essentially it was a flow-through bath that was fed with untreated water from Lake Winnipeg. We deployed the bioassays along transects that closely mirrored where we were taking our samples. So we were able to do that by reviewing the GPS coordinates. They were located on buoys and fixed in place at depth. Depending on the depth we were deploying them in, it would be 2 bioassays or 1 bioassay attached to the rope. We check the mussels periodically for signs of intoxication. When mussels are affected by potassium, they become paralyzed and they hang wide open. And if they're hit with a high enough dose, their actual internal organs will start to hang out of the shell. So it's very obvious when a mussel is affected by this. Mussels that are affected, we're pulling them out and putting them in that recovery chamber because the measurement for mortality for zebra mussels with this process is latent. So we check them at 24-hour and 48-hour intervals, and those that had not recovered in the fresh water after 48 hours were deemed to have died. So our final results, pardon me, final results, Lake Winnipeg, or Winnipeg Beach, begun on May 24th. We used 191,000 liters of KCl, which were added to the harbor. We were able to achieve 100 milligrams of potassium, and we were able to maintain that. Water temperatures at the beginning were about 9.8, and they reached all the way up to 20.5 degrees. So the temperature came up quite quickly. We did get to 100% mortality in all the bioassays by June 1st. There were certainly some technical challenges encountered, and they were largely due to the weather conditions. So if we want to think back to the slide Lorene showed of Lake Winnipeg, where it has the North Basin and the South Basin, there's a very small, narrow area that connects the two of them. When the wind becomes strong from the south, it tends to increase the water level in the harbors, is driving more water into the harbors. So that creates a bit of a problem with maintaining concentration. So we did have some difficulties there, but we were able to overcome it and get 100% mortality. Balsam Bay was the easiest one. It was the smallest one. We easily got the target concentration up to 100 ppm, and in fact we did it in a single application in one afternoon. Temperatures again ranged from about 13.9 to 20, and we did get 100% everywhere, and there were no issues at all. Gimli Harbor, charge activities there began on the 31st and concluded on June 12th. We used a lot more potassium here because we did have some significant issues. 435,000 liters were added to the harbor. Our target concentration, again, of 100, we had that no issues at all, and the water temperatures, again, span between 9.8 and 20.5 degrees Celsius. As of June 8th, we had our target concentration everywhere, and coincidentally, that was the day that the curtain failed at that location. So this retractable membrane curtain tore directly in half on a Sunday morning. I remember it like it was yesterday. And it wasn't able to be replaced immediately. We did have a replacement on hand, but the dive access we needed to was restricted due to adverse weather conditions. So it was wide open for 3 days. During that time, the concentration of 100, which we'd had everywhere, dropped to between 30 and 50. So essentially, once we put the new curtain in, we had to recharge the system, and essentially we did it twice. But we were able to reach 100% mortality. And then finally, Silver Harbor, again, activities began on June 6th and concluded on June 9th. Again, much lower level of KCl added to the system, 144,000. We did get the 100 ppm target, and temperatures 11 to 18, and again, we got complete mortality on all the bioassays by June 12th. So the eradication attempt itself was completely successful. The harbors we blocked off and put bioassays in, our results showed that we killed everything. Unfortunately, what nobody knew at this time and couldn't have known is that mussels were in fact present in the greater Lake Winnipeg. So they continue to flourish today. But the big takeaway here is that our success here, our success in Virginia, confirms the viability of these open water treatments. And I believe that as important or more important than the actual control agent you're using is the procedure and the strategy you use to apply it. If you just dump a tanker truck full of chemical into the water, you're really rolling the dice, and I think your chances of success will be seriously limited. It needs to be a surgical, well thought out approach. And finally, Lorene kind of talked about, all the things that were going on in that period of time during the winter before getting this implemented. I truly believe that the province of Manitoba and their staff really moved heaven and earth to get this done. If you think about it, they got this done in 5.5 months with a product that they'd never used before. They'd never had any exposure to zebra mussels. And the product needed to jump through a bunch of hurdles to get to an approval stage. And they got it done, and if we'd had a little more luck on our side, the result could have been different in terms of the Greater Lake. But in terms of what we did at the harbors, I'm quite happy. And I think that's all I have, and I'll hand it back over to you, Lorene.
Thanks a mil, Dan. I did want to mention in the end, I'd gloss through the summary of the regulatory approvals. In the end, for being able to apply potash, we received a research authorization permit from PMRA, and so that's how we were able to carry on with pursuing this treatment. So, as Dan alluded to, before we knew what the results are 2 years later, there were some things that we needed to follow up with or had hoped to follow up with post-treatment and once the barriers were pulled out. One of them was potassium monitoring. We were really hoping to delineate the plume following the barrier removal and monitor the time it took to reach background concentrations within the harbor and outside of the open water area. We had proposed to take water samples within the harbor and along a superimposed transect or grid outside of each harbor opening, and then, as feasible, determine if any freshwater bivalves were affected within the plume. So, needless to say, we had some challenges with delineating the plume, largely attributed to the fact that we weren't set up to continuously monitor the area to delineate it. And by not set up, I mean we needed to use AIS staff because they had the potassium probe, so they were busy doing a number of things. We ended up not always having enough people and or the boats. As Dan alluded, there were some challenges with Winnipeg Beach. The barrier sort of became a sail and ended up being pulled out at the very end, and so our monitoring couldn't occur immediately post removal. And then we had barriers like Gimli and Silver Harbor that came out, within on the same day, if I recall. So there were a number of logistical challenges that made this difficult. So I present this slide really as an observation. I wouldn't want anyone drawing any conclusions from it. When you look at the values on the right-hand map, Winnipeg Beach, this is Winnipeg Beach. In pink are the sites and the values, the potassium values when sampled on June 3rd, and then the yellow is June 4th. And you'll see that, immediately following, well, not immediately, but the several hours afterwards, we had concentrations of 73.6 down to 46.9, nothing over here. And by the next day, concentrations were down in the 4 to 5 range. And I guess my concern here is, so is that strictly from dilution, or because we weren't able to monitor the movement of that plume, did it actually move along with the current or wind? So that's the caution in wanting to make any conclusions. Similarly, with the length of time for the concentrations to drop, it really depended on the sampling location And so in this case, inside the harbor, what I really wanted to note is that up at this point here, 16.9, this was already, again, a few hours afterwards, there was an incoming stream at the very end of this harbor that helps to dilute. And as Dan mentioned, with some of the issues with the treatment, there is a lot of exchange between the greater lake body, water body, and the harbor through these sessions that are set up when there's a predominantly north wind, and it increases water levels from 1 to 3 meters, if I'm not mistaken, on that south end basin. So the values went down in some cases within a couple days, and typically within a month within the harbors, the detections were what we would have considered background. We did notice one dead native mussel along the shore immediately outside of the barrier at Winnipeg Beach. That was the only mussel. We were not able to sort of dive within the plume area. Visibility within Lake Winnipeg is a challenge to begin with, and so it was really a visual assessment along the shorelines to see if there was anything, any dead native mussels. And what was interesting was when Dan and the crew were pulling the barriers from each of these harbors, the number of snails on the treatment side that were attached and thriving quite well. So it obviously seemed to, from that level in the chain, not have any effect on snails, and one might want to extend that to other organisms as well. I threw this picture in. I don't know, and actually when I look at it, if you'll be able to see it, but right along here, this is Winnipeg Beach looking from the shore. There is this darker color, which we actually think was, we could visually detect the plume. One of the reasons we're thinking of that is we took a sample inside this plume area and outside. It was 46 point some on the inside of the plume, 7 point some part per million on the outside. So, you know, at least at that point, space and time, it would almost seem like we could have visually outlined the plume area. So we needed to determine the success of the treatment, which Dan had alluded to, and we also needed to determine if there was an in-lake population of zebra mussels. So we did a bunch of monitoring for veligers inside and outside of the treated harbors. We have the MV Nemeo, which is run through the Lake Winnipeg Research Consortium. It typically does 3 cruises, a spring, summer, and fall cruise. There are 60-some stations that samples are taken from, and so they were collecting samples on our behalf during the summer and fall. We had navigational buoys to check, and infrastructure like St. Andrew's Lock and Dam and the hydro facility and docks. So early to mid-July, we were very excited. No veligers inside or outside of the harbors. And then on July 30th, we got some samples back from the Nemeo sampling in the South Basin, and that was our first detection of veligers out in the open water. So needless to say, there was a population out in the basin. So what's the situation now in at the end of the field season in 2015? Not looking great for Lake Winnipeg. In general, zebra mussels are found now at almost all the sites, sampling sites, and these little dots are the sampling sites from the Nemeo. So zebra mussels were found, veligers were found basically at all these stations in the South Basin, and at greater densities. They've been found in the channel, and they were found in the North Basin at one site on the east side, and then through some work done by Sharon Young, doing her master's work, she detected veligers near Grand Rapids. So, and just in terms of numbers, you'll see we've jumped from 25 as a maximum number of veligers at a site to over 2,000 or over 2,500. So definitely numbers going up. In terms of the settled critters, we found for the first time by the end of the open water season this year that they were settling on the substrate samplers that we deployed in all the harbors around Lake Winnipeg. And in comparing densities, that they have increased substantially. So we jumped from 88 meters squared in 2014 to over 100,000 in 2015. We were getting reports of zebra mussels along the rock groins attached to wood, attached to native mussels and washed up along the shoreline. And this is really what some of the watercraft coming out of the Gimli Harbor after this open water season totally encrusted with zebra mussels. Last week we were out to Gimli Harbor, and one of the Lake Whitefish vessels was dry docked, and you will see this line here that literally was zebra mussels encrusted from the water line totally around the whole surface of the boat. So they are responding in a manner we had anticipated, but I have to tell you, it's still startling to see it unfold in front of our eyes like this. And then we had the other disappointing find of zebra mussels in the Manitoba portion of the Red River for the first time in June. The timeline within the Red River was, of course, the first detection in Pelican Lake in Minnesota in 2009, and then at Wahpeton, North Dakota, 2010. From that time, we'd been sampling annually at Emerson, this site up here, and June was the first time we detected veligers in the sample. Called our colleagues in North Dakota. They went out and sampled 6 sites along North Dakota. Every one of the sites had veligers. So not really sure what happened there, whether they just, jumped down, established, and continued to move down the Red River as they established, populations in ponded areas, but it's certainly not going to help the cause for Lake Winnipeg. And we then ended up with zebra mussels in Cedar Lake. This is this lake here. It is connected to Lake Winnipeg through the Little Saskatchewan River. There is a hydroelectric development right there. But it's upstream of Lake Winnipeg. Justin was just reminding me. So this would truly represent an infestation due to a infested watercraft, potentially, because there's no connectivity. You have to physically take your boat out of Lake Winnipeg or somewhere else to put it into Cedar Lake. And let's go there. So this is what we're left with. We have a number of areas of concern, obviously, now throughout the middle of the province. We have invaded waters. Oh, pardon me, let me go back. But soon to be invaded, given the downstream connectivity and natural dispersal. So, and then we have a number of border crossings, international and provincial. So it's twofold, both trying to prevent the spread from our invaded waters to other water bodies and prevent the introduction of AIS into the province. So we have stronger legislation now to help us with that. New provincial AIS legislation. There's federal AIS legislation that involves the CBSA, Canadian Border Services Agencies, to administer the prohibition of zebra mussels, quaggas, and Asian carp into certain parts of Canada. We will be operating watercraft inspection stations at pinch points to intercept the highest volume of boater traffic, not unlike our colleagues in Alberta and BC, and increasing communications informing of AIS concerns, new legal requirements, and actions that will prevent the spread. Ultimately, really this is just too large of an initiative for a government to undertake. It really does come down to changing or influencing boater behavior to help minimize that spread. And those are all the individuals, hopefully, or agencies that truly made this attempt a success in terms of turning things around in a tight time frame. And I thank you for your interest in this topic.
Thank you, Laureen and Dan. That was very informative, very thorough. We have been collecting a few questions as you've been speaking, so we're going to go through those. And as a reminder, please, participants on the webinar, feel free to type your questions into the questions pane and hit submit. We can get those and answer them for you. So the first question we have is from Mike Booth, who wants to know what was the conductivity of the lake water? He had seen a recent talk about potash interactions with water chemistry, and that found it was ineffective for quagga mussels at high conductivity, but effective at lower conductivity levels. Dan or Lorene, speak to that?
Yeah, I can kind of speak to it a bit. I had seen that paper at the recent zebra mussel conference, and that was the first time I'd been alerted about the connection between conductivity and the success of potash. So we certainly didn't incorporate that in any of the testing we did prior to starting the treatment in Lake Winnipeg. Now, I don't know if you have any background conductivity readings, Lorene. I'm not sure.
All I can say at this point is I don't know exactly the values for conductivity within Lake Winnipeg, but we did do a quick assessment from lake water quality data that is collected off the lake, and compared it to sort of the limits that are in the book by Mackey and Claudy, and there really wasn't a variable there that appeared to have the potential to limit any life stage of zebra mussels. Is that your recollection? We were hoping for one, too.
All right, thank you. Next question, we had somebody wanting to know about potash treatment and its potential impacts on other organisms.
I can tell you from our experience on it, the concentrations that we're using for acute mortality for mussels is 100 parts per million. Now, it will still work at lower concentrations than that, probably down as low as 30, but that would be more of a chronic exposure. Generally, it doesn't impact any fish species. In fact, LC50s for rainbow trout and even Daphnia magna are significantly higher than our target concentration. But if you have a shell, it won't like that. So if there are any non-target mussel species, they will be impacted by the presence of potash in the water.
Thank you. So Lorene, I know you talked a little bit about your containment area and strategy going forward, but I think this person asked the question in terms of when you were doing the treatment efforts, did you have a strategy for keeping boats that might potentially be infected from leaving the lake while you were doing the treatment?
While we were doing the treatments, we've had a containment strategy that's been concurrent with or without, quite frankly, the treatment of the harbors. In terms of them moving out, well, once the harbor was treated, actually, it was probably one of the better places for the boats to be moving out from, because there was zero evidence at that point of any sort of success within the harbors, so minimal opportunity to transport away from. We were set up to try, in that first 2 years, we really had to sort of work from high traffic boat launch sites to intercept traffic. So we were at Gimli Harbor, Winnipeg Beach, Balsam Bay, as much as we could be, often rotating through, both to be used as a communications piece, really, to show people what they needed to do, what the concerns were, and then to decontaminate any that posed a concern. When we first found the outbreak in late October, the advantage there was that really the risk, given the water temperatures, were low in terms of being able to have veligers in the water column. The other thing to consider is that for our commercial fishermen, really those boats are dedicated to Lake Winnipeg. Even the smaller skiffs, our commercial fishers fish by area, and so a lot of their equipment and gear is contained to that water body. I hope that helps answer the question.
Yes, thank you. So the next question we have, are there endangered native mussels in Lake Winnipeg, and was that a concern for you?
Well, we certainly we ended up getting a species at risk permit. Within the harbors themselves, there wasn't frankly a concern, because this was already dredged or degraded habitats. We got the species at risk permit basically because the one species that we have, the maple leaf mussel, really a riverine species, the nearest location, if I could get well, I can't map. Balsam Bay on the east side, there's a river quite a bit north of there that has zebra mussel, or let's hope not, has maple leaf mussel. And so really we got it just to show that we were trying to be diligent of potential concerns and address those. So no maple leaf mussels are known to inhabit Lake Winnipeg.
Thank you. So I think you both talked a little bit about stakeholder engagement and concern, but we had one person ask, was a public relations plan developed and implemented prior to and during the treatment? So if you want to expand a little bit about that, that would be helpful.
Certainly. If there's one lesson learned, I think it really is exactly that. You know, we went with a national framework because we didn't have anything specific, and quite frankly, the national framework worked nice, but we didn't have in advance any of those sorts of communications packages prepared. We are very fortunate that our colleagues in Minnesota and Wisconsin were sending us up their bulletin, like their releases, and other jurisdictions were helping us with suggestions. But when it came right down to it, we had to still pull together, you know, the stakeholder list, determine what would be the most, you know, effective and efficient ways to meet with these stakeholders. And unfortunately, given the resource capacity, we really fell down in our abilities to communicate consistently and frequently enough with stakeholders so they felt that they were engaged in the process.
Thank you. We have a couple of questions regarding the cost for treatment. So if there's any cost information you can share about both, I think, the cost for the treatment product itself and then the broader effort would be helpful.
Dan, can you speak to
do you want me to just speak to the cost of the actual treatment itself?
Yeah, and I'll try. I've got some figures here that speak to the departmental costs.
Sure. The actual treatment itself was approximately 800,000 Canadian, and that took into account the changes to the curtain that we had to make at the last minute, and also takes into account the extra chemical that we had to use because of the adverse weather conditions that caused the malfunction of the silt curtain. So yeah, it's about 800,000. It likely would have been far less than that had we not had the issues that we did ultimately have.
And then from a department, and this is just really a rough approximation, we probably incurred close to 100,000 in terms of permitting requirements, so getting signs and advertising done. Really, as Dan alluded to, when we had to go to the ability to allow boaters to have access in and out of the harbors, we ended up having Park Patrol man those sites 24/7 through the duration of that whole event, so that they were operating them. So you know, the safety protocols and requirements at these sites for these staff to operate during those time frames, the cost of the staff, we had divers come in at one time, and stakeholder meeting costs, yeah, it was about, it would have been just under 100,000.
And Dan, is there an average cost per liter that you could quote?
It's hard to do cost per liter because the potash is a commodity that the value fluctuates quite, you know, significantly from year to year, so it's hard to get a fix on it that way. But I can tell you, in Virginia 10 years earlier, that one was about 365,000, and that includes the chemical, the labor, the whole 9 yards. So moving forward to Virginia, it was more simply because we used a lot more chemical. I mean, that was a major cost in it.
Right, thank you. So this question might be for Laureen, and it is, do you have any estimates for how old the mussels were that were found in the harbors, or how long they had been there?
Well, this was the thing. We're finding that they seem to do quite well within their first season of growth. And so originally, when the SAC looked at the results, they thought that the mussels were indicative of a 2-year growth, until they realized we were pulling them off of infrastructure that was being removed annually from the water. And so it was at that point then that, seemed to come to a conclusion that these were actually representative of that year's growth. And so that is why in the end we sort of thought, well, it would point to the fact that this could very well be a first-year infestation issue.
Thank you. This one looks like a question for Dan. At the targeted 100 parts per million effective environmental concentration, what was the expected time to an 100% mortality?
That's dependent on the water temperature, and during that time of year, the temperature is a moving target because things are getting warmer. So typically what we find, because potash, for anybody who's not aware, is typically used in fire protection systems most frequently. So our experience with that gives us fall temperatures. So you're anywhere between, 10 to 14 degrees in that neighborhood. So under those types of conditions, it takes about 7 days, and that's inclusive of the actual 48-hour latent recovery period as well. As the temperature gets lower, it takes longer. When we've done Millbrook Quarry in Virginia, the water was quite cold there at the bottom, and it took in excess of 30 days to get mortality in the bioassays that were under 5 degrees C.
We were certainly, Dan, if I can jump in there, at one time trying to get AIS to consider doing an under ice application, and in the end, their concerns about the ability for the product to be evenly distributed throughout the harbor area, and then secondly, how long it would actually take at those low water temperatures. We were still running into an open water season with potential implications to, infringing on access to and from the harbors.
Yeah, and just to kind of build on that a bit, I think that the under ice application, it seems like a good idea, but if everything has to go perfect, and if it doesn't, your hands are tied, you can't do anything to make it mix up better. And I think the results unfortunately we saw at Christmas Lake for that type of application have borne that out.
Thanks. So we are right at the end of our hour, but we do have 2 more questions. So if it's all right, I think we'll go ahead and answer those and then wrap up. So related to that train of thought, we had somebody who asked a more broader, maybe open-ended question about the applicability of the treatment to any body of water. So if you could comment on that.
Yeah, I mean, you're going to be limited by the size of the water. So it becomes cost prohibitive when you get into larger volumes of water. So, and again, you need to kind of replicate that closed off system like we'd had in Millbrook, and then the process it tends to be quite easy. But I'm not 100% sure, but if you're talking about large type lakes where there's hundreds of millions of gallons of water, then it would be probably cost prohibitive to actually load that all up with 100 parts per million.